Gravitational redshift is the lengthening of a light wave into longer and thus redder wavelengths as the wave is coming out of the gravitational well of a dense object in space as observed from a lower gravitational field. Let's break apart this very long definition. First thing you need to know is that a gravitational redshift is the lengthening of a light wave. When you lengthen the light wave, you're going to make the wave longer. So it's into longer wavelengths. And if you're going into longer wavelengths of the electromagnetic spectrum, you are aiming for the red side of the electromagnetic spectrum, which is longer wavelengths. So we say the lengthening of a light wave into longer wavelengths. Well, what's the source of that? Well, there's got to be some kind of gravity source that's causing this stretching of the wave. So this wave is coming out of a gravitational well of a dense object in space. So let's look at an example here. Here we have a neutron star, which is a very dense object in space and has a high gravitational pull. Now, a neutron star emits most of its light in the X-rays. So likely the source is going to be somewhere in the blue colors at its surface, blue to violet. Now, if we have a photon coming out from the neutron star that is violet, it's going to come out of the gravitational well of this dense object, and the gravity is going to pull or stretch that wavelength into and toward the red side of the electromagnetic spectrum. So we might see the wavelength change colors from green to yellow to orange to red and possibly into the infrared and radio. So the lengthening of this light wave into longer and thus redder wavelengths as the wave is coming out of the gravitational well of a dense object in space is gravitational redshift, but you have to be observing it from a lower gravitational field. You can't be sitting here right at the surface of the neutron star looking at it. You got to be way over here, let's say at planet Earth, which has a much less gravitational field, and you're observing this light wave coming towards your eyes on planet Earth, and you're seeing it as the color red. Now, it doesn't have to come from the source of the neutron star. It could be coming from another star. So you could have a wavelength of any kind of object. Maybe it's blue, and it's going to pass into the gravitational well. And then we start shifting into this gravitational redshift because that light wave is going to come out of the gravitational well into the color red and even towards the red side, so infrared or radio, and it's going to come towards your eyes, and you might see it as this red colored object.